So far we discussed about the gram atomic masses, gram molecular masses, and molar mass. Now let's move to the mole concept. You know that banks have an extremely large number of coins of various denominations, and counting of such a large number of coins is a difficult job. So in banks, what they do, they weigh the coins rather than counting them. And the bank people, they know that a fixed number of a particular coin will always have the same mass. This means that from the mass of a particular type of coins, they can find the number of coins. So basically, what they are doing, bank people are linking the mass of coins to the number of coins present. So in chemistry, scientists also link the mass of element or mass of compound to the number of atoms or molecules present in them, and that is done through the mole. So scientists count atoms and molecules by weighing them, not by counting the number, but actually they weigh the atoms and molecules. And it has been found by performing experiments that if we weigh an element equal to its atomic mass in grams, then it contains 6.022 into 10 raised power 23 atoms of the element. Now, the gram atomic mass of the element as well as 6.022 into 10 raised power 23 atoms of the element both represent 1 mole of an element, right? So if we weigh similarly, if we weigh a compound equal to its molecular mass in grams, then it also contains 6.022 into 10 raised power 23 molecules. And again, in this case also, gram molecular mass as well as 6.022 into 10 raised power 23 molecules, they represent 1 mole, right? So mole is nothing but it's a link between the mass of atoms or molecules and the number of atoms or molecules. And the number 6.02 to 10 raised power 23 represents the 1 mole, represents the gram atomic mass, represents the gram molecular mass. Okay, it depends on the element or compound. So the group of 6.022 into 10 raised power 23 particles of a substance is called a mole of that substance. It means that 1 mole of atoms, if we are having atom, then 1 mole of atom is equal to 6.022 into 10 raised power 23 atoms. And if we are having molecule, then 1 mole of molecule is also equal to 6.022 into 10 raised power 23 molecules. So it's obvious that we can have a mole of atoms or a mole of molecules of a substance. And this number 6.022 into 10 raised power 23, this number is known as Avogadro's number. So the number 6.022 into 10 raised power 23, which represents a mole, you can see here these numbers, it represents 1 mole of atom or 1 mole of molecule, and that number, this number is known as Avogadro's number, and its symbol is L. So we can now say that a mole represents an Avogadro number of particles of a substance. And in addition to the definite number of particles of a substance, mole also represents the definite amount of a substance, mass of a substance. Now this point will become more clear from this discussion now. See, we are having mole of atoms. We are having both mole of atoms and mole of molecules. First, we will take mole of atoms. Now, 1 mole of atom of an element has a mass equal to the gram atomic mass of the element. That is, 1 mole of atom is equal to the gram atomic mass. It's clear that 1 mole is equal to the gram atomic mass. So, let's take the element of oxygen, and atomic mass of oxygen we know is 16 units. Now this is the atomic mass. Let's represent this mass in grams. So it would become gram atomic mass, and it's equal to 16 grams. Now gram atomic mass represents 1 mole. That means this gram atomic mass, 16 grams, will represent the 1 mole of oxygen atom, right? So 1 mole of oxygen atom is equal to gram atomic mass of oxygen. And what is the gram atomic mass of oxygen? That is 16 grams. So here it means that 1 mole of oxygen atom is equal to 16 grams. So here the symbol of an element, this symbol represents 1 mole of atom of that element. If we are having only symbol O, that means symbol of this oxygen represents 1 mole. If we are having like this 2O, that means 2 moles of oxygen. If we are having 3O, that means 3 moles of oxygen. So you have to remember that symbol represents the mole of atoms. One symbol will represent 1 mole, 2 times will represent 2 moles. Now let's talk about mole of molecules. Now, 1 mole of molecule of a substance has a mass equal to the gram molecular mass of substance. That means 1 mole is equal to the gram molecular mass. In the previous slide, 1 mole was equal to the gram atomic mass, because there we were talking about elements. Here we are talking about molecules. There we were talking about atoms. Here it is molecules. So 1 mole is representing the gram molecular mass. So let's take again the oxygen. Now the molecular mass of oxygen molecule is 32 units. Represent this in gram molecular mass. It would be 32 grams, and we know the gram molecular mass is equal to 1 mole. So it means 1 mole of oxygen molecule is equal to the gram molecular mass of oxygen. And what is that? 32 grams. So 1 mole of oxygen molecule represents the 32 grams of oxygen. So again the formula O2 represents 1 mole, but if we are having 2 times O2, that represents 2 mole of oxygen molecule. If we are having 3 times O2, that represents 3 mole of oxygen molecules. And by knowing the mass of 1 mole of a substance, we can calculate the mass of any number of moles of a substance. So a mole is a substance. Mole of a substance is that amount of a substance which contains the same number of particles, atoms, molecules, or ions, as there are carbon atoms in 12 grams of carbon 12 atom. That means a mole is that amount of the substance which contains 6.022 into 10 raised by 23 particles. Either particles are of atom, molecule, or ions. And the SI unit of mole is simply mole, amount, MOL, written in short form. Okay, so mole represents two things. Mole represents the definite amount of substance. It represents the amount of substance equal to its gram atomic mass or gram molecular mass. Again, mole represents different number of atoms, either molecules, ions. It represents 6.022 into 10 raised by 23 molecules or ions. So based on this discussion here, we have studied now that 1 mole of atom is equivalent to gram atomic mass. Okay, and 1 mole of atom is equivalent to Avogadro's number of atoms, and gram atomic mass would be equal to the Avogadro's number. And with the help of these relations, we can solve numericals based on the mole of atoms. Let's have a look on this numerical. How many moles are 5 grams of calcium? That means how many moles will form 5 grams of calcium. So let's try to have a look on this numerical. Let's try to solve this. Now see, we want to find out how many moles are present, and we are given here 5 grams. That means the gram atomic mass is given. Now gram atomic mass is equal to 1 mole, right? So we can write it here that 1 mole of calcium atom is equivalent to gram atomic mass of calcium, because we know that 1 mole is equivalent to gram atomic mass. Now what is the gram atomic mass of calcium? That is 40 grams, right? So it means 1 mole represents 40 grams of calcium. So 40 grams of calcium is equivalent to 1 mole, but we need to find the 5 grams of calcium, not 40 grams. So 5 grams is equal to 1 divided by 40 into 5, and that is equal to 0.125 moles. That means there are 0.125 mole in 5 grams of calcium. Now the next numerical is, what is the mass of 4 moles of aluminium atoms? Now we are given, number of moles are given. Now we need to find the mass of 4 moles. Okay, so we know that the 1 mole represents the gram atomic mass, right? Or gram molecular mass. Now here we are having 1 mole of aluminium atom, and that is equivalent to gram atomic mass. And what is the gram atomic mass of aluminium? That is 27 grams, right? But we are having 4 moles. So 4 mole is equivalent to 27 into 4. That is equivalent to 108 grams. That means the mass of 4 moles of aluminium is 180. Now, next numerical is calculate the number of atoms in 0.2 mole of sodium. Now, again, we are having the number of moles. We know the number of moles, that is 0.2. Now, we need to find the number of atoms. Now, see, we know that 1 mole of atoms contains 6.02 into 10 raised by 23 atoms. So, here we are having sodium. So, it means 1 mole of sodium will contain these number of atoms. Now we need to find out number of atoms in 0.2 mole. Now 1 mole is equivalent to these number of atoms. So 0.2 mole is equivalent to this multiplied by 0.2. Right? Sorry, I forgot here to write multiply by 0.2. So you will get 12.044 into 10 raised by 22 atoms. It's multiplication here. Multiply by 0.2. Okay. So you will get these number of atoms. Now the problems based on mole of molecules. In the previous slide we saw the problems based on mole of atoms. Now we are having problems based on mole of molecules. Okay, again the same thing. 1 mole of molecule is equivalent to gram molecular mass. 1 mole of molecule represents these number of molecules, Avogadro's number, and again the gram molecular mass will represent these number of molecules. Now what is the mass of 0.5 mole of water? So we need to find out the mass of 0.5 moles of water. So moles are number of moles are given. We need to find the mass, and which mass? Gram molecular mass. Okay. Now we know that 1 mole of water. First we will find the gram molecular mass. Okay. Now 1 mole of water is equal to mass of 2 hydrogen atoms plus mass of oxygen atom. We are trying to find the molecular mass, and molecular mass is equal to 1 mole. Okay, so you will get 18 grams. So the molecular mass of water is 18 grams, and because molecular mass represents 1 mole, so that is why 1 mole of water is having 18 grams of mass. Okay, so it means mass of 1 mole of water is 18 grams. But how many moles are here? 0.5. So mass of 0.5 moles is equivalent to 18 multiplied by 0.5, that is 9 grams. So mass of 0.5 moles of water is 9 grams. Clear? What is the number of molecules in 0.25 moles of oxygen? Now see, number of moles is given. We need to find the number of molecules. Now we know 1 mole contains Avogadro's number of molecules, right? And we are having here 0.25 molecules. So 0.25 moles, that is equivalent to this multiplied by 0.25. And you will get it 1.505 into 10 raised power 23 molecules. So it means 0.25 moles of oxygen contain 1.505 into 10 raised power 23 molecules. Let's have a look on another numerical. Calculate 12.0, convert 12.044 into 10 raised by 22 molecules of sulfur dioxide into moles. We need to convert these molecules into moles. Now see, Avogadro's number represent 1 mole, right? That means 6.02 into 10 raised by 23 molecules represents 1 mole of sulfur dioxide. But how many molecules are present here? 12.04 into 10 raised by 22 molecules. So that will represent 1 divided by Avogadro's number multiplied by these molecules. So you will get 0.2 moles. So that means these molecules are having 0.2 moles of sulfur dioxide. So this is how you can solve different numericals, different questions based on mole of atoms or mole of molecules.